After we look at these couple more examples, you guys, uh, you'll have some time. I'd like you to use it to start looking at the assignment. The assignment's two parts or two sections. As I told you, the second section is not really due until after Thanksgiving, but don't wait until after Thanksgiving to start working on this last assignment. So I'll give you some work time today. Okay, so I'm pretty sure I didn't do this one yesterday. It's where we kind of stopped and said we'll wait till today. Where's my Hagamore chalk? So here's a dandy. We've got the inverse sine of 5 over t squared. The inverse sine of 5 over t squared. Usually I don't see kids do this, but I just want to make sure that you don't do this. Don't reinvent these rules. What I mean by that is, even though this is true, even though you could rewrite this implicitly, we came up with a better way. Because the problem when you do this is that your answer is going to have a y in it. And we tried to spend some time yesterday saying, we don't want a y in our answer. So again, don't do that. Don't scoot the sign over. You say, but I had to do that. Well, no, I'll take that back. We didn't have to do that on the assignment that you guys got back. Instead, what you want to do is you want to plug into a rule and realize that when you plug into a rule, you're finding the derivative. Sometimes people don't realize that. So let me emphasize that as soon as I start doing 1 over the square root of, as soon as I start writing that down, 1 over the square root, I'm doing the derivative. Okay, and then basically I'm plugging into the rule. Okay, it's 1 minus u squared. And this is what makes this a dandy, because u is this little fraction, 5 over t squared. By the way, it's maybe not so much of a by the way, but don't forget, that's the derivative of the outside with the inside left alone. Like technically, that's the derivative of inverse sine with the inside left alone, times now the derivative of the inside. Now, the derivative of the inside, that's an interesting problem altogether, because remember, okay, so I keep showing this, but there'll be a time where everybody will think like this. When you think of the inside, you have to think of it as a negative exponent. Okay, because if I'm going to do the derivative, it's a heck of a lot easier to do the derivative of 5t to the negative 2. I don't really want to do the derivative of this using a quotient rule, because it's not necessary. All right, the derivative of 5t to the negative 2 is a nice little negative 10t to the negative 3. Make sure you get negative 3. Now, look, if this is like a 5-point problem, I'm going to be honest, you got 2 points. You got 1 point because you tried it, and you got 1 point because you used the formula. But we need to get a 5 out of 5. And again, this might only be 2 points. So there's more to do. Basically, there is some simplifying that has to occur with what's going on under here, with this, and some other surprises along the way. So just kind of be ready. I'm even looking at my notes because I want to make sure I'm showing it to you correctly. You will see a problem kind of like this. A couple things. Negative 10. Okay, negative 10. It's like a coefficient. Let's just park it up in the numerator. We don't need to have it on the outside and the end. We can put it in the numerator. T to the negative 3. I'm fighting some of you with this. I mean, we're not getting that bruised up, but you want to flip that. I know the solution manual doesn't do it. And I've told you guys verbally, be careful how much you use the solution manual. In this case, we want to take negative exponents and we want them to become positive. Now, look what I did there. It's not too bad. I just put t cubed in the denominator. I already have a fraction, so I don't need like another fraction. Let's square 5 over t squared. Let's square that. We get 25 over t to the fourth. Getting better. Okay, you probably would have like 3 out of 5 points. Now we're up to like a 60%, 3 out of 5. Okay. Here's the thing. These t's, maybe you wouldn't know this right now, but I'm going to teach and show you these t's. They need to come together. Okay, they need to come together. So how do we do that? We got to do a little work under here. Okay, the work is that I need a common denominator. I'm going to just write over top of the number 1. I'm going to write over top of it as t4 over t4. I'm making a common denominator because that's the only way that I'm going to be able to simplify this square root. Again, the number 1 is t to the fourth over t to the fourth. So now I have the square root of t to the fourth minus 25 all over t to the fourth. I have the square root of t to the fourth minus 25 all over t to the fourth. See this t to the fourth down here? It's ready to get its ticket to freedom. On its ticket, it says, take the square root. Take the square root of the top and bottom. But that allows me to pull that t to the fourth to the outside. So we're going to do the square root of the top and bottom. But really what that does is it makes that t to the fourth become a t squared. It's still in the denominator, whether you want to think of it as the denominator of everything, or you want to think of it as just the denominator of the square root. But the bottom line is it's not a t to the fourth anymore. It's been converted to a t squared. And this is why we did all this, so you could simplify those t's. Now I know there's like a fraction in a fraction, but once I simplify those t's to just be t, we get negative 10 over t, the square root of t to the fourth minus 25. Two more things. One, no. Don't oversimplify. Oversimplify, somebody's like, I'll take the square root of this stuff, right? Not with a subtraction sign there. So I can't take the square root of that. The second thing is, we said yesterday, I know we sort of look the other way. Don't tell anybody outside the room, but there's a square root in the denominator. It's okay. You can have a square root in the denominator. It's just the way that it works with these inverse derivatives, okay? Because basically that's part of the rule. And I guess we're going to make an exception. All right. Pretty good problem. You'll see one similar to it. I mean, I'm straight up kind of showing you almost the same thing that you'll practice in the assignment. Here's one that says, make sure you do this. So I'm going to listen to my notes, make sure we do this one. Y equals the inverse tangent of 6 over x squared. I actually kind of wonder, would you like to at least start this? You've seen me plug in now a few times. Partially, that's at least how you get started here. All you got to do is plug into the inverse tangent rule. Now, I'll just say you might want to hold off on simplifying it. I'm just kind of wondering, can you set it up? Can you start it? We're going to do some simplifying. Not that you guys can't simplify. Don't want to stop you, but probably the part that it would be helpful to listen a little bit. Nice job kind of just plugging in, which good. I expect you to be able to plug into 1 over 1 plus u squared. Equally, nice job here. Starting to get the idea. I'm doing this on purpose. You got to get this idea because the second half of the year, the secret's out. We will do everything backwards. So, there's this sort of this in-between thought about a negative exponent. All right, don't worry about doing stuff backwards yet, okay? But it'll be helpful if you understand negative exponents. So we get negative 12 x to the negative 3. Ready to kind of start simplifying this? Same thing. That's just a coefficient. So it can end up in the numerator. We have a negative exponent. Let's put it down in the denominator. Now, there is a group down here. So you got to be careful that we group it as 1 plus 36 over x to the 4th. So I did go ahead and square. All of that. Now, there's a couple options here. One of the options would be that you could distribute the x to the 3rd. Okay, it's totally fine. I'm choosing to not distribute x to the 3rd because I kind of want to build off of what I did in the other problem, and that is get you guys comfortable with this common denominator, because it seems to happen a lot. I'm talking about how the number 1, in order to add it to this fraction, needs to be thought of as x to the 4th over x to the 4th. So I'm going to go ahead and kind of just work inside the parentheses. X to the 4th over x to the 4th is able to add to 36 over x to the 4th as one common denominator. So we get x to the 4th plus 36 over x to the 4th. Now you can do a little bit of canceling. Now you can do a little bit of crossing off these x's. Do you see what's going to happen here? We're going to end up with an x in the bottom. I'm talking about the bottom of our fraction, 30x to the 4th plus 36 over x. Okay, so I cancel x to the 3rd and x to the 4th and end up with an x in the denominator. Now, don't leave an answer like that. How much have you guys worked with like fractions within fractions? Sometimes not much, sometimes a little bit. Negative 12 divided by that fraction is the same as negative 12 times the reciprocal of that fraction. Now, the reciprocal of that fraction would be x over x to the 4th plus 36. But what I just did there was I took this division problem and I turned it into a multiply by the reciprocal problem. So basically, the x that was way down here is now up here. And honestly, that negative 12, it would be nice if that was written with it. So we get negative 12x all over x to the 4th plus 36. We basically multiplied by the reciprocal. Okay, it's good and simplified. We don't have like multiple fractions. And of course, the x's have all been reduced. Anything you want to ask about? We're going to do one more problem. You might notice that we didn't do anything with inverse secant. Let's talk about inverse secant. It's got that absolute value symbol there.
So when you multiply the x over x to the 4th plus 36, How does it say x plus 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 minus
Trying to think kind of what to say and write here, just trying to think about this. So we've got this fraction, okay? We're doing the reciprocal of the fraction. Now, when I do the reciprocal of that fraction, look where this ends up. It ends up on the bottom. But the whole fraction is picked up and it's multiplied now. It's no longer divided. So this fraction, as I pick it up and flip it over, I guess there's no more like bottom. It would just be 12 over 1. Okay, that's good. It would be 12 over 1. So, yeah, there's just one bottom, which is where that flipped to. Good. Okay, let's do inverse secant. Really, you don't have to be scared of it. You just have to plug into the formula. And I'll show you one. So inverse secant of 2x plus 1. All right, I know I didn't like prove the formula. We only proved the first formula, but they all have a similar feel to them. They end up with this 1 over. Now it gets a little different. We have this absolute value of u. That'd be the absolute value of 2x plus 1. Here's the bottom line. There's really nothing that you can do with that. That doesn't mean you erase the absolute value, but it basically means whatever I plug in for x, maybe I plug in -5 or -10, but whatever I plug in for x, I'm going to end up with an absolute result. That's all. It just has to do with the slope. Okay, the slope has to come out in that part to be positive. The rest of this here, same thing, just kind of keep plugging in. Looks like we get a little u squared. That's 2x plus 1 squared. And then, of course, -1. The -1 is always part of that formula. All right. As I've said already, there's nothing really to do with this absolute value. So it's just make it part of the answer. You have to look under here and say that there's something that could be simplified. I'm referring to the 1 that's inside of this and the -1 that's on the outside. Of course, the only way to make that work is to actually FOIL this. And if I FOIL this or square it correctly, I get 4x squared plus 4x plus 1. And then I still have that -1. Careful.
Don't you have to multiply by the derivative of the inside?
Holy smokes, you do. Good call. Thank you. What would be the derivative of the inside, Emma? 2. Yeah, that was not a purposeful blunder, but it's a good learning opportunity to make sure you multiply by the derivative of the inside. Thank you. So we don't really have a 1 up here anymore, do we? It's a 2. Yeah, let's make that 2 go up there. Again, I just want to make sure we're not leaving anybody behind here. 2x plus 1 squared. That's like a FOIL, or that's like a pattern, but you end up with a 4x squared and a 4x. Okay, if you have to work that through, make sure you get both those 4x's. It's these 1s that are going to cancel. And so now I have 4x squared plus 4x under the square root. You didn't think you signed up for an algebra class. Well, a lot of calculus, at least right now, a lot of calculus is algebra. I'm going over problems that you will see, at least you will see some similar thoughts in your assignment. We're not done yet. We're not done yet because this square root of 4x squared plus 4x, you should kind of feel like it's got a 4 in there. Okay, now it's got a 4 in there. Instead of rewriting the problem over and over, I'm just going to kind of work on the inside here, and we're going to factor out a 4. Again, I don't want to recopy the problem 1,000 times, so I'm just working under there. We're going to factor out a 4, which really means root 4. Okay, root 4 is able to be simplified. All right, we get 2 over the absolute of 2x plus 1. Now we're able to take out that 4. Of course, it's a root 4, so we take it out as a 2. We still have the x squared plus x under the square root. The 2's can cancel. Thank goodness, though, that we put that 2 there because they can cancel. So we get 1 over absolute 2x plus 1. Nothing happened there. And now a little smaller square root x squared plus x. Square root of x squared plus x. All right, basically being willing to think about some algebra, and as you work through it, finding out that in this case something can be pulled out and simplified. Not every problem has simplifying. I usually choose ones that do so we can talk about them together. As you guys start doing them on your own, that's what the solution manual is for. Use it correctly. Use it to check your work. Okay. I can share again, when I was in college, I bought a solution manual. I bought a calculus book. Maybe for you, it'll be a physics book or some other book. But I was careful not to look in the solution manual before I tried the problem. Because if you just kind of look at it, you're missing out on some of that thinking. It's easy to look at it and say, oh, yeah. But if you don't look at it first, you have to think, what's the, oh, yeah. And then you can check your work. Okay, I want you to become that person. Okay, well, you have some time to start the assignment. Certainly after lunch, I want you to have that time. And then tomorrow we'll start the last section of this chapter. Woohoo.